AC through pure inductor. Consider a pure inductor of inductance L connected to a alternating voltage V of t equals Vm sin omega t. The current I of t will flow in the circuit. The expression of inductor current I of t is given by I of t equals 1 by L integral V of t dt, where L the self-inductance, which equals 1 by L integral Vm sin omega t dt, that is equal to 1 by Vm by L integral sin omega. The expression for current I of t equals Vm by L minus cos omega t 1 by omega, that is equal to Vm by omega L minus cos omega t can be written as sin omega t minus pi by 2. So the current I of t equals Vm by XL sin omega t minus pi by 2, where XL is the inductive reactance. Rearranging the expression for current I of t can be written as I of t equals Im sin omega t minus pi by 2, where Im equals Vm by XL, which is the maximum current in the circuit. Phase angle relationship. The applied voltage in a pure inductive circuit equals V of t equals Vm sin omega t. The current flowing in that circuit is I of t equals Im sin omega t minus pi by 2. Comparing these two expressions, comparing the expression for voltage and current. The current lags voltage by an angle pi by 2. That is, as the voltage has started to increase in the positive side, and once it had reached the positive maximum, the current starts to increase. So the current and voltage have a phase angle difference of angle pi by 2 radians, or an angle of 90 degrees. And here current is said to be lagging, or the current lag voltage, since voltage has come first. Current comes in the later phase. Coming to the phasor diagram, assuming that the phasors rotate in the anti-clockwise direction, so the voltage phasor and current phasor will be pi by 2 radians or 90 degrees lagging the current. So the current lag voltage by an angle pi by 2 or 90 degrees. Power in a pure inductive circuit. The instantaneous power in a pure inductive circuit is given by P is equal to Vi, that is the product of instantaneous value of voltage and instantaneous value of current. Substituting the expression for value of voltage and current, the expression for power can be written as P equals Vm sin omega t times Im sin omega t minus pi by 2. That is, power P equals Vm Im sin omega t cos omega t. Rearranging this expression, the expression for power can be written as P equals Vm by root 2 Im by root 2 sin 2 omega t. Now, for one complete cycle, sin 2 omega t happens to be 0, and hence power in a pure inductive circuit is 0. This is evident from the waveform. This is the voltage waveform and the current waveform. The instantaneous value of power is the instantaneous value of voltage and current. So during 1/4 cycle, this is the power, and power is in the negative half cycle, negative part, and the next quarter cycle the power is in the positive part. So calculating the power for 1/2 cycle, these two power will get cancelled, or the effective power in 1/2 cycle reduces to 0. So it means that in a pure inductive circuit, the power consumed is 0, or the inductor does not consume power. This can be concluded that in a purely inductive circuit, During the first quarter cycle, the power supplied by the source is stored in the magnetic field set up around the coil. In the next quarter cycle, the magnetic field diminishes and the power that was stored in the first quarter cycle is returned to the source. This process continues in every cycle and thus no power is consumed in the circuit. Thank you.